Hello, everyone. Let's get started. We're going to talk about machine learning, okay? But first, a few details about us, okay? My name is Laurent Picard. As you can hear, I'm French. I live in Paris, and I joined Google one and a half year ago. I'm based in the Paris office, and I focus on Google Cloud Platform. I'm a developer advocate. And in a previous life, I worked for 17 years in the ebook industry. I was one of the makers of the first ebook device in Europe back in 1999. Okay, so I've worked a lot in embedded development software, but eventually also in the cloud because devices got connected with time. But a few details about you. Who is a developer in the audience? Yay, almost everyone. Cool. Do we have data scientists? I'm not. Don't be shy. A few data scientists? Okay, I don't see you. Okay, maybe one or two. Are some of you already using machine learning somehow? Okay, okay. And cloud services? Okay, about 10% of each. Okay, so I wanted to start with this quote from Arthur C. Clarke because many times I've seen something that looked like magic. It felt like magic, but actually it was just technology that I wasn't aware of or I didn't know how it worked. My goal today is to show you, maybe to get you feel some of the magic of machine learning, but especially for you to understand that there's no magic, okay? But first of all, what's a conference? You're all here, we're all here. It's human learning. So how does it work? You have slides, that's data, right? And you get off of this with information. And machine learning is exactly the same, right? You have data as an input, and what you want is information, okay? And that's the secret. How does it work? So initially, the experts have been trying to mimic the way we think our brain works, okay? For that, we are using many, many examples. And as a result, we manage to solve problems. We don't always understand exactly how it's working, but we succeed in solving problems. So that's the key here, and sometimes the magic. So quickly, how does it work? For instance, if we want to recognize cats from dogs, then you will provide many, many pictures of cats and dogs and indicate the output that you're expecting. And when you've trained your neural network model, then you can propose a new picture, and here it will tell us it's a dog, okay? Quick chart, just to give you an idea about how it is important at Google. So those are the number of projects that include a machine learning model, a neural network in the project. So this is an exponential use at Google. And you can see that many, many different machine learning features have been integrated in many different products. So for instance, as of today, if I type an email in Gmail, it will propose me to autocomplete some sentences, and it works pretty well. Okay, so we are developers, and as developers, there are three ways today that we can benefit from machine learning. If you are an expert, then you can do hardcore machine learning, and this is a field where some people have been working on this for 30 years. Some of them for 70 years. I hope they retired, but this is a field that has been live for a long time, and we benefit from that today, from many, many different algorithms, a lot of theory, and a lot of experience. I'm not a machine learning expert, so this is why I want to share with you today the two other ways. So we can use machine learning APIs. So those are web APIs that you can request. Some of them also work on embedded devices, so on smartphones or IoT devices. These APIs are ready to use, so you can integrate them immediately in your product. So I've done a demo. You will see this is something you can do in a matter of hours. You can really integrate them directly. And then, so they are existing machine learning models. But then there's a new solution called AutoML that we will see in a second time, where you will be able to build yourself your machine learning model. Okay? So 3 ways we're going to see 2 of them. First of all, so the APIs, we call them building blocks. So it's easy. It's really like Lego bricks, right? You can take one of them or a few of them, and you can arrange them like you want in your architecture. They're ready to use. So it means we have a full family here, for instance, where as an input you can give anything, text, pictures, videos, and even speech. And as an output, you will get information, or sometimes you will get the same data, but in a transformer way. Okay? We'll have an overview of what you can actually do today with APIs. The first one, the Vision API. So this is my favorite for personal reasons. When I learned computer science, we did a lot of picture manipulation. We developed algorithms. We tried to detect edges to recognize objects or persons. It was pretty hard, and when we had an algorithm that was working, that would work, eventually you would propose different pictures and it wouldn't work anymore. But with machine learning, that's the magic. It's able to adapt to new pictures. It works on new pictures. Okay, so a few examples. I'm based in Paris, so I start with a few pictures from Paris. Okay, so this is a very basic picture of the Eiffel Tower. And the API is going to tell me that this is Paris, is going to give me an ID, and also the location of this place in the world. Okay, but that's easy. Anyone here guessed that this was a picture of Paris. So I took a different picture with an Eiffel Tower, but not based in Paris. It's actually in Las Vegas. And the API is able to recognize it and tells that this is a Paris hotel and casino, and this is in Las Vegas. Okay? It's also able to tell me that there are other pictures like this one or similar pictures on the web. Okay, but I live in Paris. I know it doesn't look like Paris at all. There are too many lights, right? A lot of stuff around the Eiffel Tower, so it's not Paris. So I took a new picture, and this time I flipped it, I skewed it, I zoomed in and cropped it, and this way anyone from Paris would tell me, and I would first say, oh yeah, this is the Eiffel Tower in Paris. But this is actually still the Eiffel Tower from Las Vegas. And the API doesn't get it wrong. It still works, telling this is the Paris Hotel and Casino. And if you think about it for a few seconds, why was I wrong? It's because there's something here, maybe, at the bottom, and there's nothing in Paris. Or maybe something here on the Eiffel Tower. But really, it looks like the Eiffel Tower from Paris at night. So here, this is where the model works better than me. Okay. Then I will use different pictures or samples about the Tolkien universe. It's another I like very much. So I took this time a picture from New Zealand. This is where the movie The Lord of the Rings was shot. And a Vision API is able to give me labels, okay, to tell me what's in this picture. So it's telling me it's about the nature, there's a plant, a sky, grass, everything is correct. It's also able to tell me that there's text. You see the small sign here? So it's telling me that there's English text, but it's pretty hard to read because it's using a fancy font with many stresses above each vowel. So this time, it got it mainly right, but a little bit wrong. You see, no admittance, and there's a space missing between except and on. It should read except on party business. Okay, so it works pretty well. Small mistake. Then it's able also to detect faces. So I took a picture of Gollum, rendered in 3D, and it's able to tell me there's a face. It gives me the location of the eyes, the mouth, everything, and also tries to detect emotions. And what it tells me is that this face is angry, and that's correct. Gollum is most of the time angry, right? And here's the JSON result that we get. The level of confidence, the position of the face in 3 dimensions, and the position of everything, and the likelihood of different emotions or picture features. Okay. If there's something famous in the picture, so what we call an entity, a web entity, something that a famous object, famous thing, or famous person that you can find on the web, then it will tell you. And for instance, I took this picture. I had never seen this picture before. It's very rare. It's used only on one Spanish newspaper. And so I cropped it, and it still works. It's telling me that this picture is about Tolkien. And it tells me where it's coming from. Also giving me pictures or web pages that look similar. So, for instance, a human being in a forest or against a tree. And also, you see, I still have an entity ID. So I have an identifier that relates to Tolkien. And that's pretty useful because sometimes famous people have different names. So I can still relate to this ID to identify Tolkien. And Tolkien as a son, Christopher Tolkien, so with a different ID. And depending on the context, the machine learning models are able to tell whether it's the son or the father. Okay, and so that's an API that you can call directly. But of course, you find open source client libraries. I'm pretty sure you will get your favorite language here. So this is a Python example, just to show you how easy it is. You create a client, you provide the content, you call the feature you want here, face detection, and then you can immediately use the results. Okay? But enough talking. I propose you to have a live demo. That's what I prefer. So all the features that you see today, you can almost all of them use or test them on your browser. So here, I'm going to use pictures that are not coming from the web, or at least the first ones are pictures I took yesterday. So yesterday when I arrived, so what I did first, I removed the metadata. I learned from the team that they're not using the metadata by default, but just to make sure, I removed everything. So this is a picture I took yesterday. This picture is unique, right? For sure, it looks like other pictures elsewhere. And the API is able to tell me that this is the train station of Antwerp, right? So I feel a little bit of magic here because 6 months ago I was trying that in other cities and it didn't work that well. And it looks like the model keeps being trained and just keeps being better and better. So I know exactly where this picture was taken or where it's supposed to be. There's no GPS information in the picture. It's telling me, yeah, that this is a building, classical architecture. I know this is the train station. Okay, must be enough. And just on the right of this location, there's this landmark. And it's also able to detect what it is. So I don't know if it's using the text or not, but it's able to tell me that it's the zoo, the Antwerp Zoo, right? So likewise, there's a statue, a monument in the city. Okay, cool. I have the link to the Antwerp Zoo. And also, I have the different locations here. So I have 2 blocks of text, and I know exactly what it is. Jardin zoologique. And Felis tigris must be the name of the tiger here. Okay. So it works pretty well with pictures that are unique that I took yesterday. So I took pictures from the web this time. So this one, maybe you don't know him. I didn't up until this morning. This is a picture coming from the web, but what I did is that I zoomed in, I changed the colors, so there's not 1 pixel in common with the original picture, so it's telling me that there's a face, a very neutral face, right? No emotion. Okay, glasses, bird, business person. So the funny thing is that whenever someone is wearing a suit or a tie, it's going to tell me that it's a business person, okay? A mustache, okay, right? I have bird. Bird is better than mustache. And here it's telling me that it's Charles Michel, okay, cool. So, and if I want to know who he is, I just have to click here. And yeah, I have a pretty good idea here. It must be the Prime Minister of Belgium. Cool. Okay, and then let's try with another picture that I took from a movie to show you a different feature. So here, okay, surprise. Yeah, I don't know if the zombie is surprised, but there's a face and there's a zombie, a jaw. Yeah, everything is right. And the interesting thing here is that I can know that this picture is possibly violent. So if I want to filter the content, if I don't want my kids to see that, then I can use this feature, okay? So that was for the live demo, but still those are pictures that I selected, right? So I could still be cheating, and I don't want to cheat with you. So I propose you to do a live demo and to get your smartphones connected, okay? So either in 4G or in Wi-Fi. I hope the Wi-Fi will stand the load. Okay, so what did I do? So this is a serverless architecture, a very small demo, very easy to set up. And on the right side, I have buckets. So buckets are folders in the cloud. So I can put my files in there. So this is just like I had 4 different folders in the cloud. And then I have functions here. So I developed code that I deployed to the cloud. So just code, right? No server, nothing, just I have a set of functions. And whenever there's a picture uploaded here, it will trigger this function, which will call the Vision API. So I will get the analysis about this picture. I will store it here. So with the picture and the analysis, the JSON stream, right? I have all the information I want about the picture. And what I will do is do some composition as I have the location of the different faces. And I will store the result here, the composite photos. And then I will crop the largest. So if you take a picture and there are 3 of you, I will take the face with the largest number of pixels. I will crop the face, the largest one, and I will store the result here. And we're going to see in my small Python backend what the results are. Okay, so welcome to the demo, the Stash Club. There are 8 rules if you remember the Fight Club movie, but there's just one here. If it's your first time at Stash Club, then you must get your stash. Stash is mustache. Okay, so let's get started. So I propose you to get connected to this URL, bit.ly/devoxx.beml, or you can also, of course, scan the QR code. Okay, bit.ly/devoxx.beml. Give you some moment to get connected. Yeah, and you should reach something like that. Yeah, is it okay? Okay. So are you connected? Yeah? Okay, so let's move to step 1. If you refresh the page, then I'm going to ask you a nickname, and then you can take a picture. So please send me selfies and try to express emotions. So try to be surprised, angry, sad, and happy. Okay? I will try so. Okay, don't make fun of me, right? Okay, so this is the composition. I wanted to check if I will look like my father with a mustache, and I do. Let's try different emotions. Okay, hungry, sad. So sadness is a bit harder to detect. Surprise is a bit easier. I hear some laughs. And finally, let's be happy. Okay, let's try something. Okay, I almost grabbed my mustache. So let's see what you did. Okay, who has been angry? Oh, not many. Okay, but it's a bit hard to detect, like sadness. A bit more. I wouldn't say you're sad, but a bit more angry. Yeah. Who's surprised? Yeah. And who's happy? Yeah, cool. You're a happy crowd. And in some cases, we're not sure, so here's the reminder. Yeah, not sure about the emotions. So if you took a picture of your foot, it will not appear because the foot is not a face. Okay? Cool. So, okay. Oops. So that was the live demo to detect faces. Oh, I forgot something. Sorry. I will try to invite some guests, okay? So not these ones. So this is the bucket, the first bucket, where you have uploaded your selfies, right? Okay, and I'm going to invite these people. So just as if you used the demo and uploaded the picture. And, okay, let's check here. And you see the zombie here is blurred. I use the feature to know that it's a violent picture, so I blurred the picture on the fly. Okay. Yeah, and here we have Wolverine, who is pretty angry too. Okay, so you see it works with anything. Where is Charles Michel? Okay, not happy. Yeah, he wasn't happy. He was just neutral. Okay, must be around here. Okay, let's not waste more time. Okay, so you saw how the Vision API, a Vision API can help you understand what's in your pictures. Likewise, for a Video Intelligence API, you can get insights about your videos. So it works like pretty much like the Vision API, but you have time as an additional dimension, right? And so what this API can tell you additionally is the different sequences that you have in your video. So it means you can actually index all your videos. So I prefer to show you this demo because it's pretty simple to understand. So this video has been indexed by the Video Intelligence API. So I have here all the different labels. So water, dress, leaf, spiral galaxy. So there's a spiral galaxy at the beginning.
The world is made with tiny bits.
Okay, correct. There are humans. A longer sequence at the end. Yeah, correct. Electronic device, cathedral. There's a polar bear here.
You will fix something.
So you see? So still pretty easy to use. It takes a bit more time, but because of course it's just not one picture, but a full video. So you can launch batches, and then you will get insights of your videos. Okay. So next, so we've seen pictures, we've seen videos, then text. So with the natural language API, so it's often called natural NLP, natural language processing. So understand how text is built, okay? So the first feature is to analyze the syntax. So I took the description of Tolkien on Wikipedia. Tolkien was a British writer, poet, philologist, and so on. And the NLP will tell me, the NL API, that first it's English, right? Okay. And then it will give me all the relationships, the types of every word or item in this sentence. And one feature that I like more above everything is the lemma feature. So with lemmas, you know, in purple, I can actually simplify everything, especially verbs, to work with the canonical form of each verb. So it means I can maybe analyze a corpus of text and work in a canonical way, so like with IDs, identifiers. Okay. So next, it's like for pictures, it's able to recognize entities. So if I give the same sentence, it's going to tell me that there are three different groups, three classes. The first one in red are persons. So Tolkien is a person, that's right. And I have the ID here of this person. And if you remember, that's the exact same ID as when I try to analyze a Tolkien picture. So I can know that we're talking about picture in the text or that we are seeing Tolkien in a picture. Pretty cool. Likewise, British so is related to a location, to United Kingdom. And then at the end of the sentence, there are three books, and each of them is recognized as a work of art, which is correct. And I also have an ID and a link to the Wikipedia page. Okay. Then, like for pictures, we can analyze the sentiments in the text. So what I did is I took two different reviews, one from the New York Times, originally, when the book The Hobbit was released, and a more recent one by this young lady, Pauline, who didn't like the book. So the New York Times review was pretty positive, and Pauline didn't like the book at all. And so the NL API gives me for each sentence a rate, a score, from -1 to +1. And like that, I know whether the sentence is positive or negative. And it works. These sentences come from Pauline's review, and these sentences come from the New York Times review. And also, of course, most of the time, the sentences are just neutral, right? So it works to be able to know how the text is structured, but what it's talking about, and also whether it's talking about it positively or negatively. And the last feature is being able to classify the content. If I give the same sentence, it's going to tell me that it should be classified in books and literature, and it's 97% sure about it, which is correct. Okay. Likewise, some Python code, you create a client, you give the content, you call analyze sentiment, and then you can use the result right away. And that's what I did. Okay, just to mention Ocado. Ocado is a British retailer, a big one, and they have teams of data scientists. And they have been working to analyze the content coming from the users, and especially text content. And they realized that it was easier to use the NL API because it was just working great for them. If you look on the web, you will find some articles that it's pretty interesting because they explain what they did to improve their process. They didn't increase their teams, but with the same team, they're able to do more. They're able to be more efficient. And maybe one example, If they have an email from an angry customer, the email will be pretty negative, right? And what they can do is treat that email in priority, thanks to machine learning. So be more efficient. Okay, so I think I forgot something. Yeah, no. So still about text, the translation API. So I won't get into many details because you have all used this, I think, Google Translate. Just one detail. So I was a simple user of Google Translate before joining them. And about 3 years ago, I noticed something as a French user trying to translate in different languages. From one day to the other day, the translation got a lot better. So I was happy, but so it meant I was using Google Translate more. And I got the explanation since I'm at Google. Actually, the team switched from a mainly statistical model to a purely machine learning model. And that's where the improvement in quality got from. Okay. So still a sample. This time I have more comments than code, right? I have just 2 lines of code. Create a client, then call translate, and you have the result immediately. It works on HTML too, so you can translate your user's email, for instance. Business example, Airbnb, 60% of their users don't speak the same language, so they're using the translation API to basically translate everything, and thanks to that, they reach a lot of more users. Okay, so what I propose you is to go on the demo, and this time you're going to send me any feedback. So first, let me show you how it works. So I have some sample sentences in different languages. So I really do love raspberries, and I hate watermelons. And that's what I said in a few different languages. Okay. Oh yeah, I think I forgot to show you. Yeah, what I did just I added these two in the backend. When you will send me some text, if it's not in English, I will translate it to English, but it could be any language, and then I will run the text analysis on it. So I'm using the two latest API we talked about. Let's show you the different messages. So you see. Here it's not translated, but here everything is in English translated, so you know what this Chinese sentence or this Japanese sentence means. Okay, here are the entities I talked about, mainly raspberries and watermelons. And here are the sentiments. I really love raspberries, okay. Okay, but now it's your turn, okay? So if I move to step 2, and if you go next or refresh, you can text me anything. So think about sending, I don't know, try to talk about someone or something you like, someone famous or not, or something you dislike, okay? And I will type something in French. Try any foreign language. Remember, everything will be translated to English. Okay, so if you don't speak French, you should know, okay, no misspelling, okay. And you can send a few sentences. So let's check what you told me. Okay, some Spanish. Okay, Trujillo, most beautiful town in Spain. Come and watch Juvo. Some advertising. Any person belonging. Okay, too long to read. So okay, it didn't get translated. This one. Some Latin, some German, some Dutch, some Portuguese, some Dutch still, some Danish. Oh, I don't know this language. Okay, Dutch, Danish, Roman, okay, okay, thank you. That's not Swedish, this one. Okay, I should learn all the different languages. There are too many, I don't know. Okay, So everything got translated. Then, here is everything you talked about. So some people talked about Westworld, Java, some countries. I did talk about Devoxx. Devoxx is famous enough to have its own Wikipedia page. And so Devoxx has its own ID, so I can use it. Someone talked about Google, someone talked about Charles Michel, so that's not me, and about FAT. So still a Raspberry's Room event, okay. Okay, so 11 persons were mentioned. And finally, the sentiments. Thank you for inspiration. So yeah, you're positive here. You love Java. So some some love announcements. Okay, welcome. Okay, let's see. Let's check neutral ones and who's been. Cake is lies, sad, I hate watermelon. So you've been very nice. Thank you. Thanks a lot. Okay, so you see in a few lines, it's been very easy to understand what you've been telling me just with 2 APIs. Okay, next, let's with speech. So we can do, of course, and for a long time you've been able to do that. You can do, as a developer, speech-to-text conversion, and the opposite too. So speech-to-text, you have an audio stream with a voice, and you get the text transcription. What's interesting today is that it can be robust to noise, thanks to machine learning. Most of the time, previously, it wouldn't work that well. Can be context-aware, so if you're in a professional use case, maybe you can provide some dictionary, for instance, in an hospital, with a lot of medical terms. And that's the building block for any assistant today, right? You can speak to your phone, you can speak to Alexa, to Google Home, to any word assistant, and it would transcribe your speech to text and then analyze the text. And likewise for videos, you can also input a lot of speeches and then index everything in your speeches, so you can know where every word has been pronounced in the different speeches. Okay. Like Airbnb, Azar, so they're not that famous, but it's a matchmaking app. And Azar, like Airbnb, is translating everything for their users, who can be in any part of the world. But moreover, they are using the speech API to convert speech to text and then translate it. Okay, but let me show you. So I wanted to integrate that in my demo, but there's something a lot easier now. So let me just open a browser. And I can search by voice, for instance. What I forgot to tell you is that it's real time. What is the temperature in Antwerp?
It's 13 degrees in Antwerp right now.
So you saw it's real time, and when I started to pronounce Antwerp, it understood something else. That's exactly the way we work. When you're talking with someone, it's depending on the context. Sometimes at the beginning of the sentence you understand something and then you change and you understand the meaning is different. So this is how it works too, and of course at the end you have the correct answer or result. Let me check something. What is the temperature in Paris? Okay. What is the temperature in Paris?
It's 13 degrees in Paris right now.
Okay, so I can stay here. It's the same temperature. Okay, so you see that's also something that you can integrate pretty easily to understand a human being speaking to you. Okay, so the opposite now, text-to-speech. What's funny is that it's pretty new at Google. And text-to-speech has been here forever. So when I made my first ebook device, or 20 years ago, I worked on a text-to-speech, so what we call TTS. So I embedded a text-to-speech engine in this ebook device. I was very proud. I developed it. Not the engine, but the integration. It worked perfectly. You could push play, and it would read the book aloud. It would say, yeah, it would read the book from the start to the end. So it was working perfectly, but nobody used it at all, or used it for 30 seconds. It was because it was a robot, like a robot talking to you. And as of today, it's maybe the most advanced machine learning API if you compare to human quality. So this is new at Google, never done before at Google because the quality was not there. So it has been developed by DeepMind. That's a team mainly based in London. And it's called Wavenet. So that's the voice you can hear in many different languages. And the breakthrough here is that it's human-like and it's real-time. And more than that, in 1 second, you can actually generate 20 seconds of Wavenet voices. Okay. Let me show you an example. So here, there's a recording from the original person, and there's a Wavenet generation. Okay, let's try to see if you hear the difference.
She earned a doctorate in sociology at Columbia University. She earned a doctorate in sociology at Columbia University.
So with my teammates, we've been playing. We have many different samples like that. We've been trying to guess, to detect the Wavenet voice, and we failed. Actually, that's the first one. The first one is the Wavenet voice here. So it's very hard here to detect. That's why I'm saying it's the most advanced one. And that's why today you can have assistant talking back to you, and they're pleasant to hear. Okay. So now we've seen how you can use existing building blocks, right? Lego bricks. But sometimes the results will not please you. They won't work for your use case. And this is where AutoML comes into play. You will be able to customize, you will be able to build a machine learning model just for your own needs, right? So the way it works is you provide your own training data, then you can launch a training, the first one, from 1 hour, for instance, to see whether it works or not. And then you can iterate, provide more samples, fix the samples. That's the core of the training, the samples. It's the most important part. The training is automated. And then when you're happy, you can deploy it and serve it. And then you can use it like the other APIs. You will be able to do custom classification, for instance. So it's a new family that is going to grow. It's been for about 1 year now. And what you can do today is provide images and text, and then get custom classification or custom translation. Okay. So let me give you this example. If I take these two pictures, the Vision API will give me basically the same results, because those are clouds in the sky, right? So I have the same result. But what if I wanted to know that this cloud is a cirrus and this other cloud is an altocumulus? Then I can use AutoML Vision. And even without being a developer, I can industrialize it as a developer, but I can use it just as a simple user. So what you do, this is a demo that has been done by my teammate, Sarah Robinson. So she took samples of the different clouds. She created 5 labels here. And she said, OK, these pictures are altocumuluses and so on. So that's the sampling part. Then you can launch the training. You can start with 1 hour. It's fully automated. And then you get the results here. Okay? You get 2 main metrics, the precision and the recall. So she did a first training of 1 compute hour to check, and then a more advanced one of 3 compute hours. And the precision improved a little bit. So when you launch the training, then you have to evaluate your model. On one side, you have the results that the model is giving you, and on the other side, you have the expectations. So let's imagine that this square are all the possible results. On one side, the model is going to provide you some results and not provide you some other results. And on the other side, there are the results that you expect and the results that you don't expect. Sorry. And those are 4 different cases. So what the expert did, let's say that it's a detection model. If the model is detecting something, it's called a positive. If it's not detecting something, it's called a negative. And then like that, you can give a name to these 4 different cases. So if the model is a positive, if the result is positive and is expected, then everything is right. It's a true positive. But if it's not expected, then that's a mistake. So it's a false positive, right? And then for the negative, so the results that the model is not detecting, if it's expected, then it's incorrect. It's a false negative. And then the rest is OK. Those are the true negatives. So these terms are important for the sampling part and the evaluation of your model. And then you have 2 different metrics. The precision metric, so where you want to minimize the false positives. So you want to minimize the mistakes, right, in your model. So it's a measure of quality for your model. And the other metric is the model recall, where you want to minimize the false negatives. So you want to minimize the results that you're not getting, but that you're expecting. So this is more a measure of quantity. And of course, a model is not perfect, like a human being. So it's up to you to decide which of these metrics you want to favorize. A small data viz, when you want to evaluate your model, you can have a look at the confusion matrix. And on the diagonal, you will see where it works well. Here, it's working badly on altostratus. So it means we are to provide maybe more samples of the altostratus or more quality pictures. And then you can try it yourself. So this is a picture I took in Poland. And it's telling me that it's cumulus, which is correct. Cool. Yeah, I will pass that. I will publish my slides. Yeah, I prefer, this is the first for me. So what I did, I trained a model myself, and I tried to detect 3 new expressions. Let's do it, because I have, a bit more than 2 minutes. So I wanted to try to recognize faces with tongues out, or people yawning. I want to check if you're bored, or if you're very bored, people sleeping. Okay, so I used AutoML. I provided about 200 samples of each label. Ideally, it's 1,000. But let's check it. It's really the first time. I finished it yesterday. So I'm curious about the results. So let's try to take pictures. And you can yawn, you can sleep, and you can stick your tongue out. Okay, so that's the easiest one to be detected, I think, with this model right now. So I don't know if I'm sleeping or not. Or maybe you can take a picture of your neighbor. And then, yawning is pretty hard because there are many different expressions in yawning. Okay. And you can take a few ones. Okay, so let's see who got his tongue out. Yeah, it seems it's working. Oh, sorry, there are new ones. Cool, it works. Who's yawning? One. Who's sleeping? Nobody is sleeping? Did you try? Did someone try to sleep? Yeah, okay. 2, okay. So I will get the samples. Or maybe they were still being processed. Yeah, tongues out, yawning, and nobody sleeping. Okay, so I did it in half a day, so that's pretty short. Okay, time is running. So we've seen how you can use existing APIs and how you can build your own API. And of course, if you want to do more machine learning, you can do it yourself. There are many different frameworks. One of them, TensorFlow, is an open source library that you can use on any laptop, and of course that you can deploy in the cloud. Okay. For the record, TensorFlow is the most popular machine learning repo on GitHub, and by far you have also Keras or PyTorch. And time to wrap up. So here are a few pointers if you want to try this. Okay, I give you some time if you want to take a picture. Okay. And so my goal today was for you to have an overview of what you can do without being a data scientist. The magic here is that it's pretty easy to do, to integrate. So I hope it gave you some ideas. Feel free to send me any feedback with this small link, or follow me on Twitter. I hope you learned a few things today and that you got a few ideas. Thanks a lot for having me.